Number 11 says find -3 1/5 divided by 1 3/4. So most of the questions we looked at for questions 1 through 10 were adding and subtracting, converting fractions to decimals, and vice versa. Number 11, we're actually going to start using our multiplying and dividing rules. And if I had to pick one that was my favorite, multiplying and dividing with fractions is my favorite thing to do. If I was adding or subtracting, I'd switch over to decimals, but if I'm multiplying and dividing, fractions are my favorite. Now, when you're multiplying or dividing with fractions, though, you have to change the numbers into improper fractions. You can't leave them as mixed numbers like you can when you're adding or subtracting. So let's start with this first one, -3 1/5. Hugo, what is -3 1/5 if you write it as an improper fraction? That's right, -16/5. And so what Hugo did is he took 5 times 3 plus 1, which is 15 plus 1 is 16 plus 2, and put it all over 5. That's how you turn a mixed number into an improper fraction. So let's try that for the next one. Austin Eads, what is 1 3/4 as an improper fraction? Okay. So 7/4. And if you don't want to write the negative signs in your work, you don't actually have to when you're multiplying and dividing because it's pretty easy to determine right away. If I have one negative number, is my answer positive or negative? Negative. So I know my answer is going to be negative. I don't actually need to right there. I don't need to write the negative next to 16 if I don't want to. I don't want to confuse you. All right, can we cancel?
Yes.
No. Because we have to keep change flip it first. You're right. You can only cancel when you're multiplying fractions. So before you start canceling the 16 and the 4, we have to keep change and flip this fraction. As Logan just said, we're going to flip flop the 7/4. So 16/5, keep that fraction the same. Change the division to multiplication. And flip 7/4 to 4/7. What is that called again when you flip a fraction upside down, Kara? The reciprocal. That's right. Now let's cancel. What cancels? The 16 and 4 don't cancel now? You're right, they're on the same level. You can only cancel a top number with a bottom number. What about 16 and 7? 4 and 5? Okay, well, we're not wasting our time at least, because if we are checking to see if it cancels and it doesn't, that tells us it's not going to reduce at the end. So we don't have to check at the end. So if we check and it will not cancel, it will not reduce. Across the top, that means we have to do 16 times 4. What is 16 times 4? Anybody know already? Isaiah? 64, which you could totally do and off to the side if you needed to. So 64 on the top. And then what's 5 times 7 on the bottom? 35. We can do this one together. Okay, you don't have to raise your hand. We can all do it. Remember though, we did say it was going to be negative. So -64/35 is my final answer. I'm looking here in the instructions. The instructions say you have to write it as a mixed number. That's the nice thing about doing your chapter 2 review on formative. I make the instructions. I make the answer key. So you don't have to change it to a mixed number, especially on your test. You can leave it as an improper fraction. But if you did, 35 goes into 64 once with 29 leftovers. It would also be negative. So if you wanted to write it as a mixed number, it would look like that. But I'm going to stop at -64/35. I'll accept both answers on your test Friday. Number 12. This one has us multiplying, not subtracting. That's what the parentheses are there for. So we don't see that negative as a subtraction symbol. 4.3 times -2.6. Chloe, when I multiply a positive number and a negative number together, what's my answer going to be? It is going to be negative, so I don't have to worry about writing the negative symbol anymore. I can just think of it as 2.6. In fact, since we're multiplying with decimals, I don't even need to look at the decimal points. I don't have to line them up when I'm multiplying. I can just pretend it's 43 times 26. The only thing the decimal points help me do when I'm multiplying is determine how many decimal places should be in my answer. So 1 plus 1 is 2. I should have 2 in my answer, but we'll cross that bridge when we get there. Let's do this one together. What's 6 times 3? Sorry, together. 18, carry the 1. Oops. 6 times 4? Plus 1 more. We're going to drop a 0 because now we're multiplying by 20. 2 times 3? 6. Nothing to carry. 2 times 4? 8. And then now I have to add these together. This is why I think adding and subtracting with decimals is easier than the multiplying and dividing. 8 plus 0. 5 plus 6. 11, carry the 1. 1 plus 2 plus 8, also 11. Now I can determine how many decimal places need to be in my answer. 1 and 1, as we said, makes 2. So start on the far right side, count over 2 spots, and make those 2 spots decimal places by putting the decimal right between that second and third one. I was going to say between the ones, but that wouldn't be very specific. So 11.18. And remember, we said that because this is a negative times a positive, Chloe reminded us that it should be negative 11.18. Number 13. Number 13 has us multiplying 5 6, negative 4, and 2 7ths. The parentheses are here, but I don't have to start where the parentheses are. It's all multiplication, so I'm able to do it in whatever order I want to do it, whether the parentheses are there or not. It's all multiplication. This actually looks similar to a question from your chapter 2 review. There was one in the review that had you multiplying 3 numbers together with fractions. So 5 6 times, how do I write 4 as a fraction, Hugo? That's right. Times 2 7ths. I'm not going to write the negative in my work. Because just like last time, if we have one negative number, our answer is going to be negative. So we can just forget about writing it and write it at the end. Do you see anything that cancels here? Draven? There is something that cancels. Oh, yes. What do you see? 1 and 2. Not 1 and 2. Not 1 and 5. 1's not going to get any smaller. Caitlin?
6.
How about 6 and 2? Yeah, 6 and 2 can cancel, which is the nice thing about canceling, because it can be any top number with any bottom number, even if they're far on different sides of the problem. So the 2 obviously goes into itself once, and 2 goes into 6 how many times, Caitlin? How many times does 2 go into 6? 3 times. Okay. So on top then, or sorry, do we have anything else that cancels?
No.
4 and 7, 5 and 7, 4. Okay. So on top then we have 5 times 4 times 1. What does that equal to? 20. On bottom we have 3 times 1 times 7. 21. And that's not going to reduce. And we did say it was supposed to be negative. So negative 20 over 21. I like multiplying with fractions. Easier than adding or subtracting them, right? All right, number 14. Number 14, we haven't seen this in a while. Number 14, what are those symbols called next to the negative 3/5? What are those, Gavin? Absolute value symbols. You're exactly right. So the absolute value of a number is how far that number is away from 0. How far is negative 3/5 away from 0? 3/5. Yeah, that's why when we see those absolute value symbols, that tells us whatever's inside, we need to get rid of the negative. If there's not a negative there, then it's good to go. But if there's a negative inside, because it's a distance, it can't be a negative answer. So the absolute value of negative 3/5 is positive 3/5 plus 3/4. All right, can I cancel? Hugo? The 3 and the 3? No. Caitlin? You can't cancel addition. That's exactly right. You're only allowed to cancel with multiplication. And you'd be surprised how many people try to do that on their tests. I'm constantly writing, can't cancel addition. You can only cancel if it's multiplication. If it's addition or subtraction, you must find a what? Common denominator, that's right. So we can't even cancel. We have to, instead, we have to find a common denominator, which means I'll have to change my numerators as well. Is there a number you can multiply 4 by so it turns into 5? 4 times 20 is 5?
No.
4 times 1? 4 times 2? 4 times 5 is 5? So what you're saying then is that there isn't a number I can times 4 by, and we're gonna have to change both? Okay, so I always try to check though, if, don't change both if you don't have to, but this is one that we're gonna have to change both denominators, and yes, it is going to be 20. 20 is the first multiple of 5, that's also a multiple of 4. And to get there, I do 5 times 4 and 4 times 5. Which means I have to do 3 times 4 on the left side and 3 times 5 on the right side. What's 3 times 4, everybody? 12, and 3 times 5, 15. I'm adding them together. There's no negatives to worry about. What's 12 plus 15?
27.
All right, 27 over 20. Does that reduce? Does 3 go into 27? Yeah, does it go into 20? Does 2 go into 27? Because it goes into 20? No? Okay. I'm running out of options here. I don't think this reduces. 27 over 20 looks good to me. Now it's an improper fraction, which I'm perfectly fine with. As long as it's reduced. If you want to change it into a mixed number, 20 goes into 27 once with 7 leftovers. So I would accept either of these answers, but I'm going to keep it improper because it's less work. All right, number 15. Now, number 15 is a different question, different kind of question here. He gives us 4 problems, and it just wants to wants us to determine if the product or quotient, which that's the answer to a multiplication and a division problem, product and quotient, if it's going to be positive or negative. That's all it wants us to determine. So for number 15, I want you to, on the blank you're writing on your paper, write the word negative, and then over a little bit to the right, write the word positive. And to make this as simple as possible, I'm going to call this problem A, problem B, problem C, and problem D. And then all you have to do is write the letter of that problem underneath either the negative side or the positive side, depending on what we determine it to be. So let's look at problem A. Negative divided by negative. What kind of answer will I get, Miley? Positive. They will pair up and make a positive. That's right. So under the positive side, put letter A for problem A. It doesn't even ask us to do the problem, just wants us to determine if it's positive or negative. Example B. Those are absolute value bars again. What's the absolute value of negative 2.16? Gavin? That's right, 2 and 1600s, 2.16, so we positive, right? So essentially we have a positive times a positive. What's a positive times a positive? Positive, so B is also going to be written in that positive category. For problem C, 5/6 times negative 2/3. Is that going to be positive or negative? Negative. There's no negative for the negative 2/3 to pair up with. So this one's going to be negative. And then for D, again, absolute value symbols are going to make that positive 2.75. What's a positive divided by a positive? Also positive. So for number 15, that was pretty easy. A, B, and D are all going to give us positive answers, and C is going to give us a negative answer. A lot of it, of course, having to do with the fact that those absolute value symbols back from chapter 1 are in some of those problems. All right, number 16 it's a lot. 3/8 times the quantity 3/4 plus 5/6 written in parentheses minus a half. Number 16 is going to take quite a bit of work for this. It's like 3 problems in one. So I'm going to use the order of operations as I do with every math problem. Parentheses, exponents, multiply and divide, add and subtract. PEMDAS, please excuse my dear Aunt Sally. What comes first when I'm looking at this problem, Isabel? The parentheses. I have to do the parentheses first here. So inside the parentheses is 3/4 plus 5/6. Do I have to have a common denominator when I'm adding? Yes. Is there a number I can multiply 4 by to turn it into 6?
Oh.
Is there a number I can multiply 4 by so it becomes 6? No. So I'm gonna have to change both denominators. So what's the first multiple of 4? That's also a multiple of 6, Gavin. 24 is a common denominator. It's not the first one though. It's 12. Yeah, now 24 works, and you could use 24. You just have to reduce it. 24 would work. It is a common denominator, but the least common denominator, the lowest one I can use is a 12. They both can be turned into 12s. I can do that by multiplying 4 by what? 3, which means 3 by 3, and multiplying 6 by what? 2. Okay, so 5 by 2. All right, Olivia, what is 3 times 3?
9.
And what about 5 times 2? So 3/4 plus 5/6 is the same as 9/12 plus 10/12. We have a common denominator, so we can add these now. Olivia, back to you. 9 plus 10. 19. All right, so 19/12. Well, the first part's done. I'm running out of room, so I'm gonna have to write over here. You guys might have to, obviously, work down the side of your paper as well. So now that I've done the parentheses, I've got 3/8. And then I can write it in parentheses, or I can put a multiplication symbol, but this is 19/12 minus a half. What would the next step be on order of operations? Caitlin? Multiplication. Yeah, so it's a good thing we didn't turn 19/12 into a mixed number, because we're gonna have to turn around and turn it right back to an improper fraction, because you have to have an improper fraction when you're multiplying. You can't leave this mixed number. So I'm multiplying this part right here. Do you see anything that cancels? Cash, what do you see? Yes. What goes into 3 that would go into a 12? 3, yeah, okay. So it goes into itself once, and how many times does it go into 12? 4. Anything else cancel? Driven? The 2 and the 9, where are you getting the 2 from? Oh, so this is the subtraction part. We can't look at that yet. We can only cancel when we're multiplying, right? So we're just looking at the multiplying section right here. So how about the 4 and the 19? 4 and 19 don't cancel? Why not? You're right. Yeah, there's no factor that goes into 4 that also goes into 19. What about the 8 and 19? Still no? What about the 8 and the 4? Wait, they're on, yes, you're right. They're on the same level, right? Hey, good. That's all right. That's why we're doing this. 8 and 4 on the same level. They would normally cancel if they were on 2 different levels, but I can only cancel a top number with a bottom number. So if nothing cancels, we're ready to go ahead and multiply those. What's 1 times 19? 19. Thank you. And on the bottom, what's 8 times 4? 32. Which brings me to the last part of this problem, subtracting a half from it. Can you cancel when you're subtracting? No. Do you have to find a common denominator when you're subtracting? Yes. Is there a number that you can multiply 2 by? So it becomes 32, Miley? 16. Yeah, so we only have to change one of the fractions instead of changing them both like we did last time. We only have to change one. And so Miley, what is negative a half, or sorry, minus a half? What is that going to change into? 30 seconds. Close, good job. Okay, so we have 19 30 seconds minus 16 30 seconds. Normally, when we do subtraction, we do what? Normally. Kara? Keep change opposite? Do we have to do that here? Or do you know what 19 minus 16 is? All right, we could do key change opposite. We could change it to 19 plus negative 16, but it's gonna give us the same answer. Kara, what is 19 minus 16? So we're gonna get 3/32. Does that reduce? No, there is no common factor that they share. There's no number that goes into 3 that also goes into 32. So we are finished with this problem. That was a doozy. I would expect that one to be like the last problem, because if you can do this problem, you can do just about anything with fractions. We multiplied them, we added them, we subtracted them in this problem. We didn't divide them, but we've already done one of those. All right, number 17. The table shows the elevations of 4 mountains. Which of the mountains are taller than Snowy Mountain? Snowy Mountain has an elevation of 1 1/5 miles. I'm supposed to determine which of the other 3 would be taller than that. They give me these numbers written in fraction and decimal form. What do I need to do in order to compare them? I'm getting the same hands. Susie, I haven't heard from you yet. How should I write these numbers so they're easier to compare? Improper. That might help, but there's still gonna be different denominators. It'd be tough to determine unless I found a common denominator. You like finding common denominators for a bunch of fractions? Okay, then you could do that. What's another way, Jade? Make them all into decimals. I think that's gonna be easier. And Susie, you can disagree with me, and you can do it however you want to, as long as you're getting the correct answer. I think it's gonna be easier to write these as decimals. So let's start with that first improper fraction, 9/7. Do we have our sevenths memorized? No, that wasn't on the list I gave you of ones that I think you should know. So if I don't have it memorized, how do I turn a fraction into a decimal? Luke, how do I turn a fraction into a decimal? What's that little fraction bar me tell you to do? What'd you say? Divide. Yep, we're just gonna divide. We're gonna pretend it's 9 divided by 7. Every fraction is just a miniature division problem. Which number goes inside the division box then? The 9. Why the 9? Because it's bigger. Because it's on top. Exactly. Thank you, Peyton. So 9 divided by 7. The top dog gets the house. 7 is going to go into 9 though, because this is an improper fraction. So 7 goes into 9 how many times? Once, with the remainder of 2. Put a decimal point. Put a second decimal point up above, and drop down to 0. Amara, stop flipping that paper. Chase, how many times does 7 go into 20? You're right. What is 7 times 2? Yeah, 14. And it doesn't go in 3 times. That would be 21. So we can't have it be too big, or it can't go in that many times. So 20 minus 14 is a difference of 6. By the way, when you're doing long division, I've seen this come up a couple times. When you're doing long division, when you get your remainder, the number you get is bigger than the number that you're dividing by, it means it could have gone in there again. Keep that in mind. I've seen that come up a couple times where we've had bigger numbers on the as a remainder than what we're dividing by, and it throws our answer off. So 6 is good. 7 can't go in another time. We drop down another 0. 7 into 60. Aiden, how many times does 7 go into 60? What is 7 times 8? 56. I agree with you. 7 times 8 is 56. We're gonna get a difference of 4. This isn't gonna give us a very pretty decimal, and so I'm not gonna keep going forever, but let's just go one more decimal place, just in case we need it. And then we can just stop and say it rounds to about this then. So 7 into 40. Logan, how many times does 7 go into 40? 5 times. What is 7 times 5? All right, that's gonna give us a difference of 5. And I'm not going to drop down the next 0. We're just going to say this is approximately 1.2 285. All right, so we don't have our sevens memorized, and that would be what? They're very difficult. What about our fifths? Do we have our fifths memorized? Gavin, you do? Okay, what's 1/5? 2/10. Awesome. So 0.2, right? So this is going to be the same as 1.2. Our fifths are fractions that I think we should memorize. 1/5, as Gavin said, is 0.2 or 2/10. 2/5 is 0.4. 3/5 is 0.6. 4/5 is 0.8. Do we have our eighths memorized? Do we? They were on that list, right? They're harder, but they're on that list. If you have your eighths memorized, then what I would do is I would have you convert this 9/8 into a mixed number. How about 1 and 1/8? And then you could do whatever 1/8 is. But I know that a lot of you don't have 1/8 memorized. So what should we do? We don't have it memorized. Kara? Divide. Yeah, just like we were supposed to do earlier. Divide. Which number goes inside the division box? The 1 or the 8? The 1. It's always, as Peyton said, the top number. It's a pretty common mistake that I'm seeing. Make sure we put the top number, not the largest number. It's always the top number. Sometimes it's the largest, sometimes it's the smallest. It's always the top. We can't do 8 into 1, so we're going to put a decimal point, a second decimal point, and do 8 into 10. Alyssa, how many times does 8 go into 10? Just once. Difference of 2. Drop down to 0. Justin, how many times does 8 go into 20? Twice. What is 8 times 2? 16. Awesome. That's a difference of 4. 4 is not bigger than 8, so I know he's right. Drop down to 0. 8 into 40. 5 times. What is 8 times 5? Exactly 40. This isn't going to go on forever like the last one, or not forever, but give us a bunch of different decimal places. So this is going to be 0.125. How many of you knew that 1/8 was 0.125? Then you saved yourself maybe 45 seconds of work. 1.125. The last mountain's elevation is already in decimal form. 1.35. So what we'll do on your paper then, we'll just check off the ones that are higher than Snowy Mountain. So let's start with Blue Mountain then. Is 1.285 larger than 1.2? It is. Okay, put a check mark next to it. What about Cascade Mountain? Is 1.125 bigger than 1.2? No, it is not. In fact, if you're having a difficult time comparing these decimals, try making them all have the same number of decimal places. That might help. Now you can see that 0.125 is definitely not bigger than 1.200. What about the Brook Mountain? 1.35. Is that bigger than 1.2? Yes, in fact, it's the largest one up here. 1.35 or 1.350 is larger than Snowy Mountain. It's larger than any of them. So then that means Brook Mountain and Blue Mountain are the two that are larger. Yes. All right, number 18 is our next one. Number 18 says the table shows the change in the amount of gallons of gasoline in a car over a period of 5 days. What's the total change in the amount of gasoline over that 5-day period? Write your answer as a decimal. What's it tell us when on 4 of these 5 days, the change in the gasoline is written as a negative number? What does that actually mean? Graven? It's dropping. So what are we doing? What in terms of the car? Yeah, we're driving it, right? Yeah, we're driving, we're using gas. We use just over a gallon on day 1, a little bit more than that on day 2, day 3, less than a gallon. Day 5 was the day we spent the most driving, it looks like. What did we do on day 4? Austin? Yeah, we filled it up, or at least put more in it, right? I don't know if we necessarily filled it up, with gas prices being the way they are, we maybe didn't fill it up, but we definitely put some gas in it. So to find the change over this 5-day period, it might actually be a good start for us to figure out the total amount of gas that we used. So let's look at the negative numbers and let's join forces with the other negative numbers. When a bunch of negatives join forces, is the answer positive or negative?
Negative.
Well, what is it?
Stop.
Think if a negative army met up with another negative army, are they going to switch teams? They're gonna join, so are they gonna switch sides? No, it's still gonna be negative. So by, what I'll do here is I'll join forces with all my negative numbers, and they're gonna remain negative. But it'll tell us the total amount of gas we used this week. So, we've got 1.05 plus 1.20 plus 0.85. And then the last one's 2.15. They're all negative. So when we add them together or join forces, the answer is going to remain negative, but it will give us a good idea of all the gas we used this week. What is 5 plus 5 plus 5? Okay, 15, carry the 1. What is 1 plus 2 plus 8 plus 1? 12. Carry the 1. What is 1 plus 1 plus 1 plus 2? 5. Drop down your decimal point. We used a total of 5.25 gallons. That number is negative, representing the gases Raven said that we burned or we used. But as Austin said, on day 4, we put gas in. That's represented as a positive number. So I'm going to add the gas that I put in. Now, when I look at that problem, are we joining forces again, or are we going to war? Yeah, and the positive army wins, which makes sense because we don't want to have a negative amount of gas in our car. So the positive army wins this one. We're going to subtract, because the positive army wins, that number is larger, we have to write it on top. Yes. Our answer is going to be positive. Can we do 0 minus 5? Nope, so let's do this one together. Borrow from the 5, make it a 4. What's 10 minus 5? 5. 4 minus 2. Drop down your decimal point. Can't do 0 minus 5. We end up doing 10 minus 5 anyways. What's 10 minus 5? 5. The answer is positive 0.25. And what were we measuring our gas in? Gallons. GAL is the abbreviation for gallons. So ultimately, at the end of the week, we had 5.25 more gallons in the car than what we had previously started with. All right, number 19. Number 19 says a person who is 5.8 feet tall is standing in a pool. The top of the person's head is 1.6 feet above the water, the surface of the water. How deep is the pool? So they're 5.8 feet tall. They're standing 1.6 feet above the water, or their head or chest, whatever is sticking out of the water is 1.6 feet above the water. It wants to know the depth of the pool. I'm going to draw a picture here so we can get a good illustration of this. Nothing special. Yeah. So we know the person's height is 5.8. We know that the top of their body is sticking out, so this is obviously not drawn to scale, 1.6 feet above the water. We have to find out how deep the pool is. Cash, what do I do? Subtract 5.8 minus 1.6. You're exactly right. And Cash, do I need to line up the decimal points when I do that? Sure, like it's my, if I want to, or sure, you absolutely have to. Sure, you absolutely have to. Yeah, when you're adding or subtracting, you have to line up those decimal points. We're going to subtract. What's 8 minus 6, everyone? 2. 5 minus 1. Drop down the decimal point, and we're measuring our height in what? Feet. Another story problem needs a label. 4.2 feet. That's how deep the pool is. That's kind of like what we're going to be doing next chapter. I mean, they're literally going to have, we're going to see X's in our next chapter. It'll say 1.6 plus your height, which is X, would give you the total height of the person, 5.8, and we would have to subtract just like Cash told us to do. So that's I give you a preview of what we're doing next chapter. Equations just help us find missing numbers. Our last problem says the table shows the balance in dollars of a bank account each month for 3 months. What is the average balance of the account? Ooh, average. That's been a while since we've done average. What does average tell you to do? Gavin? It tells you to divide. Divide what though? Estimate. Gavin, go ahead and finish it. Okay, that was what I needed to hear. So we have to add it up. Add these numbers up and then divide by however many numbers there are. And since there's 3 months, there's 3 numbers. Right? So we have to add our account balance. Now, I would be happy with an account balance if I were you, right? Of $1,285.12. That'd be kind of nice to have, right? And then month 2, my account balance went down a little bit. And then month 3, it went back up. But to find what the average is, we have to add them together and divide by 3, because it's 3 months. So let's start by writing 1,285.12, 961.36, and 1,132.63. We're going to add them together. That's the first step in finding the average or the mean. What's 2 plus 6 plus 3?
11.
11. Carry the 1. What's 1 plus 1 plus 3 plus 6?
11.
Also 11. Carry the 1. Drop down your decimal point. What's 1 plus 5 plus 1 plus 2? 9. What's 8 plus 6 plus 3? 17. We only one person do this now?
17.
Thank you, Hugo. About 10 seconds too late. What's 1 plus 2 plus 9 plus 1? 13. And what's 1 plus 1 plus 1? 3. Okay, so that's what the total of all 3 months was, but we have to divide that by 3. So 3,379.11 divided by 3. When we're working with decimals, which number is not allowed to be a decimal? When we're dividing them, which number is not allowed to be a decimal? The inside or the outside number, Caitlin? The outside number. How many decimal places does the outside number have? None. So I don't need to move the decimal. Remember if it was like 0.3, remember I have to slide it over once or something like that. I don't need to do that because the outside number doesn't have any decimal places. So I'm immediately going to slide my decimal or float it up to the top, not slide it over, float it to the top, and we're good to go for this problem. How many times does 3 go into 3? Once, and then obviously 1 time again. 3 into 7. Twice. What is 3 times 2? 6. Subtract and get a difference of 1. Drop down your 9. 3 goes into 19. How many times? 6. What is 3 times 6? 18. It's a difference of 1. Drop down this one. 3 goes into 11. How many times? 3 times. What's 3 times 3? 9. Subtract. That's a difference of 2. And drop down your 1. And 3 goes into 21. How many times?
7.
Exactly 7. If it didn't give us a remainder of 0, I'd have to keep adding zeros. But this is money, and money always uses 2 decimal places, so it makes sense that we'd stop here. So 1,126.37 what? Dollars. Now we are done. If you were here and you got questions 1 through 20, we did yesterday, okay, make sure your name is on it and come turn your paper into the tray.